Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion is problems on binomial distribution. We are going to discuss about definition of binomial distribution, mean of binomial distribution, variance of binomial distribution, and solving the problems based on binomial distribution. Definition of binomial distribution. That is, a random variable, capital X, has a binomial distribution if it assumes only non-negative values and its probability density function, which is given by, this is the formula for binomial distribution. That is, probability of capital X equal to small r, that is the probability of r, which is nothing but if r is taking the value from 0 to n, then it is NCR p power r q power n minus r. Here the p represents probability of success, q represents probability of failure, and n it represents if it is a die, how many times it has been thrown, if it is a coin, how many times it is tossed, or if it is a product, what is the total number of products. So it represents n is denoted for that purpose. Next, here the q is given 1 minus p it is. The reason is p plus q equal to 1. That is, probability of success plus probability of failure, which is equal to 1. That is, the total probability is 1. So P is probability of success, Q probability of failure, N number of trials. So now the alternative notation for binomial distribution is, that is here and this, the difference is here, R is used. Here instead of R, we are using X. We are also going to do the problem solving using this X notation only. That is, probability of X equal to X is P of X. Here the B represents binomial distribution and NCX P power X Q power n minus X, where X is taking the value from 0 to n. Mean of the binomial distribution. That is, the mean of the binomial distribution, this is the general formula, that is mean formula. Summation is X is taking the value from 0 to n, X into the probability distribution. Here our distribution is binomial distribution. That is, the binomial distribution is NCX P power X Q power n minus X. So we are substituting in this the probability distribution place the binomial distribution. We got it NP. So mean of the binomial distribution is n into p. Variance of the binomial distribution is, this is the formula, V of x, it represents variance of the random variable, summation x equal to 0 to n, x square px minus mu square. Here this probability distribution is replaced by this binomial distribution. So it is replaced with binomial distribution. The variance sigma square, the notation is variance of the binomial distribution. Mu is for mean. So sigma square, it's nothing but NPQ. So mean of the binomial distribution is NP. Variance of the binomial distribution is NPQ. And n factorial can be written as n into n minus 1 factorial. If we want to continue n into n minus 1, n minus 2 factorial. More we want to expand, then n minus 3 factorial. So that's what it is written here. If it is 5 factorial, that is a number, then 5 into 4 into 3 into 2 into 1. So we stopped up to 1. Here, this and this, what is the difference? Here 5 factorial, 5 into 4 into 3 into 2 into 1, we wrote it. Here 5 factorial, 5 into 4 into 3. In middle only we stopped it, we didn't write up to 1. So 3, it has the factorial notation. Otherwise, 5 into 4 into 3 into, we want to stop up to 2, no problem. 2, we will stop with the factorial notation. Here the 6C2, the value is this position what is there, that factorial. This position what is there, that number, that factorial. These two difference, 6 minus 2, that difference of that value factorial. This is 6C2, the value. In such a way it should be written, that is NCX. The formula is n factorial by x factorial, this position factorial, this position factorial, both we should do the subtraction. The difference is factorial. That's what here the example is given in numbers. We will do the problem. That is, the probability that a man hitting a target is 1 by 3. If he fires 6 times, find the probability that he fires at most 5 times, exactly 1, at least 2 times. Now, this is the question we have to solve. There is not even a single word, this problem, binomial distribution using, we have to do. Nothing is mentioned in this complete the question. Then why we have to select binomial distribution to solve this particular problem? That is the main thing we have to notice it. Now, the binomial distribution, we know the formula, that is NCX P power X Q power N minus X. To substitute here, first thing P we want it, and N we want it, Q we want it, X, then what about X? X is nothing but specifically they are asking in the question. I want at most 5 times, exactly 1, at least 2 times. That is also X is ready. Then what about N? What about P and Q? Now, in the question if you read, the probability that a man hitting a target is 1 by 3. So what is given in the question, we will accept the target. That is only our probability of success. So the man hitting the target is our success. So the probability of success is 1 by 3. So P is 1 by 3. If you get P, then easily Q value we can obtain from that. Because the reason is, we know it, P plus Q equal to 1. If we know P, compulsory Q automatically will be coming out. That is, Q is nothing but 1 minus P. We can substitute, we can do off. How many times the man is hitting? 6 times. So, N equal to 6. Everything now we got it. Yeah, now. This is actually to avoid the careless mistake purpose. It is the mention in the rough column, it is written 0 to 6, the data which is written. Why it is 0? 6 we understood why it is written up to 6, because 6 times 1, 2, 3, 4, 5, 6. Then why 0 is? Because binomial distribution formula, just now we have seen x is taking the value from 0 to n. That is the reason 0 to n, that is according to the formula, our n is 6. We stopped up to 6. At most, here it is given, mathematically that inequality is less than or equal to. At least that mathematically it is greater than or equal to. Exactly means equal to. Now solution this is the binomial distribution formula. The man is hitting 6 times. At most the symbol is less than or equal to. So the P is given in the question, that is the man is hitting 1 by 3, that is a probability which is given, that we are accepting as success. So which is according to this problem, firing the target, which is taken as probability of success. Q, we know it, the formula is 1 minus P. So 1 minus P, what we got it, we substituted, which is nothing but 2 by 3. N, the man is hitting 6 times. So n equal to 6. The first question is at most 5 times. At most, that means maximum is 5. So here the notation, at most 5 times, mathematically we have to write P of x less than or equal to 5. So up to here we understood very clearly. But what is this part? Yes. Now this is probability of x is less than or equal to 5. Here the equal sign is there. That is the reason 5 is included. Less than 5 is there. So less than 5 means 0, 1, 2, 3, 4. So this is the data which is required for this our given question. Question solution it will become. But now 1, 2, 3, 4, 5, 6. 6 datas are there. That means 6 times we have to apply binomial distribution formula. Time it will take for specific target, that is P of x equal to 0, 1 time binomial distribution. P of x equal to 1, 1 more time. Like that up to 5, 6 times we will apply. That is also correct. And we will add up, the result will come. But we want to save the time. How to save the time? So very smart work, very shortcut way we can reach the answer. That is, this is the data which is required for this solution. For this question, this is the data required. Fine. This data is not at all required. What we are going to do, the smart work, we know it, the total probability is 1. We will subtract this. This data is not at all required. Which is not at all required, we will subtract, then the required one we will be getting. So P of x equal to 6. This not at all required data, from the total probability we will subtract, the required data will come out. Because x equal to 6, only one time we are going to apply the binomial distribution, which will save our time. Yes, the binomial distribution formula is written here. Now our n, this is the 6. Our p, this is 1 by 3. Our q, 2 by 3. Again one more place n is there, that is also 6. X, 3 places is there. I am putting the arrow mark. 3 places it is there. So the arrow mark. So we want P of x equal to 6. So 1, 2, 3. The 3 places we x is replaced by 6. 6c6 using the calculator. Otherwise, manually also we can calculate and we can do it. So 1 by 3 power 6. Here 2 by 3 power 6 minus 6. So 2 by 3 power 0. That's nothing but 1. So the answer is 1 by 3 power 6 equal to 1 by 729. This value is 1. So the next question is exactly 1 they ask. 3 parts are there. Exactly 1 is the second part. Exactly mathematically the symbol is equal sign. Yes. Binomial distribution formula. We wanted x equal to 1. So n 2 places is there. So 6. This is P, this is Q. X in the formula 3 places. That is our specific target. What is asked in the question? That is 1. We substituted 6c1 is 6. This is 1 by 3 power 1, 1. 6 minus 1 is 5. So we did the calculations. This it has become 2. So we know it 2 power 5, it's nothing but 32. 3 power 5 is 243. The final answer we got it 64 by 243. One more question, at least 2 times. Now at least the mathematically that inequality is greater than or equal to. So P of x greater than or equal to 2. Now the same thing here, the equal sign is there. So 2 is included. Greater than 2 we want it. Greater than 2 according to our question 3 is there, 4 is there, 5, 6. How many times? This is the required data. 5 times we have to apply the binomial distribution. Times. We want to save the time. This 5 times applying, time consuming. Lots of time. So we will save the time. We are noticing 5 is the required data. Unwanted data only 2. Smart work. We will do it to save the time. So what is the smart work? Yeah, the total probability is 1 minus this unwanted data. We will subtract it. That is P of x equal to 0 plus P of x equal to 1. That's what it is written here. Because if you are writing here x equal to 0 one time, x equal to 1 only 2 times, we are going to write the apply the binomial distribution formula. Yeah, this is the binomial distribution formula. So x equal to 0 we are taking. So n, the 2 places 6 because the man is firing 6 times. This is P, this is Q. X 3 places 1, 2, 3. Our specific target is 0. 6C0, the value is 1. This value 1 by 3 power 0, that is a power 0. Exponential law is 1. So this particular value is also 1. 2 by 3, 6 minus 0, 6. So 64 by 729 is the answer. We solved the first problem completely. Yeah. Now x equal to 0 we completed. Now we will move to substitute here. This part here we completed. This P of x equal to 1 we have to do it. So we can see it here. So this is place for n, p, q. This place is for x, that is our x equal to 1. 6c1 is 6. This as it is. 6 minus 1, the power is playing 5. 64 by 243. So what is the question which is asked? So P of x greater than or equal to 2. That is at least 2 times they asked. So 1 minus this. That is a smart work to save the time we did. So what are the answers we got it? So x equal to 0, 64 by 729, and this minus we have taken inside. That is the reason the plus it has become here minus 64 by 243. We have taken the LCM completely here. 729 it has become the LCM. So final answer we got it 473 by 729. Now one more problem we will concentrate. Out of 800 families, pick 5 children each. That means in the total some village 800 families are there. Each family we are going to select some, we are picking 5 children. 5 children. It is a common noun. They didn't tell 5 boys, 5 girls. Children they told, maybe the possibility girl or boy. 2 possibilities only. How many would you expect to have? Suppose when we are picking the 5 children, in the 3 boys are there. What is the probability? 5 girls are there. What is the probability? 2 or 3 boys. What is the probability? At least 1 boy. What is the probability? Yeah, these are the 4 questions we have to solve. First, in the village 800 families are there. For one family first, we will find the probability. We are not going to consider now 800 families. One family first we will do it. Yeah. For that, just now we solved one problem. In that man who is hitting the target firing 6 times. Just now we concentrated. The picture very clear about it is given to us. The man is hitting the target. Like that, here what is given in this problem? That it is somewhat confusion is there. The problem it is very clear. Probability of that man is hitting, the value is given 1 by 3, that we have taken as P and we did. We solved it just now. But here this problem, everything is hidden. So now some logic we have to. Children is a common noun. Student is a common noun. The children common noun, the basic actually definition of that probability we have to see. So when we are picking that each family, children we are picking 5. The possibility girl or boy. I will take the specific target, boy. If I get a boy, success. Then another one doubt is coming. In the question, they didn't mention only if we are selecting the boy, success. Then why to select a boy as success? Why we can't select girl as success? Yeah, that is the next doubt. It's a correct doubt also. In the question, 4 are there, in that 3 dominating boys. That is the reason we are taking boys. So if we get a boy, everything, time also we have to see. One problem, to solve that particular problem, 10 minutes we have to do. Long way, complicating, confusing, we should not extend the time also. Time parameter also, very, very important. Yes. Now, the P, so the boy. So when I am picking actually that each family, if I am getting a boy, yes, success. The probability of success. That is boy, girl. This is only 2 possibility. Total possibility is only 2. The basic definition of probability, that is total outcome is 2, boy coming means favoring that boy only one possibility. So 1 by 2, it is according to the basic definition of probability, which is a return. Everything, because children is a common noun. In that only girl is there, boy is there. Boy coming, success. Girl coming, failure. Yeah. Q, the probability of failure. So 1 minus P equal to 1 minus 1 by 2 equal to 1 by 2. So from this is the presentation like this. Reading the question, what we want it. First we have to pick what is total number, what is N, what is P. That two we have to pick. If you pick, quickly we can, towards the solution we will be going quickly. Yes, N equal to, so it's not a number of times, number of children we are picking. Number of children, 5. So the first question is 3 boys. That is probability of 3 boys. X equal to 3. Specifically, X equal to 3. Our N is ready, 5. Our P is also ready, 1 by 2. Q is also ready, 1 by 2. N we know it, 5. X is our specifically what they asked, 3. 3 boys. So X is playing the role of 3. So we substituted here. Here. These two places for N, P, Q, 1, 2, 3. Just now I circled the 3 places for X. Our X is 3. Now 5C3. Manual also we can do it. Otherwise calculator also we can use it. So 5 factorial. 5 into 4 into 3 into 2 into 1. But we stopped middle 3 factorial. Getting an idea, down we are seeing 3 factorial is there. Better if I stop the numerator 3 factorial. 3 factorial, this 3 factorial will be getting cancelled. Because of that idea only, it is stopped up to 3 factorial. We stopped it and both are getting cancelled. So 5 into 4 by 2. It's nothing but 10. So 1 by 2 power, this is, what is that? So 1 by 2 power 3. Here 3 is there. Here 5 minus 3 is becoming 2. So 3 plus 2, it's 5 is written. So we know it, 2 power 5, it's nothing but 32. So 10 by 32. The lowest form, we put it 5 by 16. So the first question, we solved it. That is probability of 3 boys. It's nothing but 5 by 16. Next, if you are noticing here, this we found for each family we found. Only one family, but in the village, 800 families are there. Then what we have to do it? Very simple thing, that 5 by 16 into 800. That's what here we have done it. We got it 250. This is the result. We obtained it. The next question is 5 girls. But our probability of success is boy. Here the question 5 girls, but boy means probability of success we starting onwards you are doing. The boy, how to give link to this? Because one family, 5 children we are picking. 5. The 5 are completely girls. But we want a boy. Then no boy. 5 children, all 5 are girls means there is no boy. So there is no boy. Mathematically how to tell? No boy it is the language of English I am speaking. Mathematically, how to speak here? Yeah, we will speak like this. That is probability of 5 girls. So connectivity to boy, no boy. So probability of no boys, no, none, nothing, everything mathematically 0. So the probability of x equal to 0. So we know it. So here 0 to 5. Why I stopped up to 5 here? Because each family we are picking 5 only. But before problem I stopped up to 6 because the man is hitting 6 times. So there n equal to 6. Here each family we are picking 5 children. That's what here it is stopped up to 5. Yes, the binomial distribution formula, and x is playing the role 0. Yeah, n places 5, p, q, 1, 2, 3. X place our specific target 0. 5 c naught, the value is 1. This is a power 0, that is 1 by 2 power 0. It's nothing but a power 0. A power 0 value is 1. So 1 by the 2 power 5, it's nothing but 1 by 32. So this is also we got it, each family we got. But we have totally 800 families. So 800 into 1 by 32 we got 25 is the answer. The third question is either 2 or 3 boys. That is the binomial distribution. P of x equal to 2 plus P of x equal to 3. First, the binomial distribution is here. Our specific target is this first we are focusing. 1, 2. Just now what I circled, it is a place of n, p, q. Just I'll put tick mark 1, 2, 3. The 3 ticks just now I put it. The place for x because our x is 2. Specific target. Yeah, we simplified it. 5c2 the value is 10. This is written as it is. Here 5 minus 2, it's nothing but 3. It is written. This 10 is written as it is. This 1 by 2 power 2, this is 3 plus 3. So 1 by 2 power 5, which is nothing but 1 by 32. So 10 by 32, the lowest form is 5 by 16. So this is completed. Next, this we have to x equal to 3. Everything is same, only this 1, 2, 3. That x place it will be taking the value 3. So the same 5c3 value 10. Here 1 by 3, here 3 is there, here 2 is there. So 1 by 2 power 5. 10 by 32, the lowest form is 5 by 16. So here also we got 5 by 16. Here also 5 by 16. So both we added. We got the result 5 by 8. So this is 5c2, the factorial. If we want to do the manually, we know it. This position factorial. This position factorial. 5 minus 2, the difference 3 factorial. The 5 factorial, we are expanding 5 into 4 into, we stopped in middle 3 only. So we are stopping with the notation. The idea based on that is the down we are noticing 3 factorial is there. This both will be getting cancelled. Then 5 into 4, 2 factorial is 2 getting cancelled too. It's nothing but 10. That's what 5c2 the value which is here replaced by 10. Similarly, 5C3 also. 5 factorial. This is 3 factorial. The difference is 2 factorial. 5 into 4 into 3. This getting cancelled. The 20 by 2 equal to 10. That's what here 10 is there. Otherwise, we can use the calculator also. We can do it. At least one boy. At least. Mathematically, we have to see the symbol. That is greater than or equal to. So, the greater than or equal to, for this at least purpose, one boy purpose, 1. Fine. Here this equal sign is there. That is the reason 1 is included. Greater than 1 is there. The greater than 1, what are the datas are there? 2 is there, 3 is there, 4 is there, 5 is there. So we will count 5 times for x equal to 1 time, x equal to 2, second time, x equal to 3, third time, x equal to 4, fourth time, x equal to 5, fifth time. 5 times we have to apply this binomial distribution formula. But this is the only required data for our question. But we don't want to waste our time. That is time consuming. We will do the smart work, which is unwanted. This data is unwanted. So better total probability is 1. Subtract that unwanted, that x equal to 0. This is the best way. This best way we can do it. Otherwise, here you can see the long way. Like this also we can do it. This problem, it is solved in the long way. That is x equal to 1, x equal to 2, 3, 4, 5. You can see when x equal to 1, they substituted. 1 minute. So 5C1, that is the expansion is given here. X equal to 1, the binomial formula, we got it 5 by 32. X equal to 2, just now the previous problem we got it. That's what it is not put it in the slide. X equal to 3 also, the third part, either 2 or 3. We solved it, these two. So it is not put it here. X equal to 4, we know it. Here x place, 4 is dominating. So 5 by 32. X equal to 5, 1, 2, 3. We got 1 by 32. So very long way. All the values we substituted 1, 2, 3, 4, 5. 5 times the binomial distribution formula we applied. We have taken the LCM. We got it 31 by 32. It is a very long method. Smart method. Just now, that is what is the question? Is a greater than or equal to 1. 1 is included. Greater than 1, 2, 3, 4, 5. 5 times. We applied it now. 1, 2, 3, 4, 5. 5 times we applied, we got it 31 by 32. Better 1 minus p of x equal to 0. Only one time we will apply. Subtract from 1. The same answer we will be getting 31 by 32. It is left to us. Either we want to do this way, fine. We want to do long method, fine. Any way we can do it. The result will be the same because the total probability is 1. If you are not getting, somewhere our careless mistake, we would have done it somewhere mistake. Yeah, the next problem is in 8 throws of a die. One die, your die it is given. Yeah, your die. Die is singular, dice is plural. Yes, 5 or 6 is considered as success. That is, we are throwing a die. How many times? 8 times. 5. If you get to 5, yes, success. 6 I get, success. But 4 if I get, failure. 2 I get, failure. Only 5 and 6 only they told. That is a probability of success. Fine. Find the mean and standard deviation they are asking. Mean of the binomial distribution, standard deviation of binomial distribution. Yes. Now, P equal to probability of, here plus is there, P equal to probability of success. That is, we know it, if throw a die, the 6 faces are there. So the 5, that is a basic definition of that probability. The die if you throw, what is the total outcomes? 1, 2, 3, 4, 5, 6. 6 possibilities. The total possibility is 6. If I get 5, favoring that 5, how many possibility? Only 1. That's what it is written, 1 by 6. That is according to basic definition of probability. For 6 also the same one. Compulsory everything, equal distribution. So 2 by 6 it's nothing but 1 by 3. So our probability of success is 1 by 3. So what is our question? That getting probability of getting 5 or 6. This is the way if the problem presentation is there. Any careless mistakes comes also, which will give an indication that somewhere we are doing mistake. Q equal to probability of failure. That is 1 minus P. So 1 minus what we got it, the P we substituted, equal to 2 by 3. N we have to see how many times it is thrown. 8 times. Mean of the binomial distribution. The mean of the binomial distribution is NP. So N we know it 8 times. What about P? Just now we got it 1 by 3. So we got the answer. The mean of the binomial distribution is 8 by 3. Variance of the binomial distribution. That is, variance, the formula is NPQ. We substituted, this is N, P, Q. All the values we picked. So N, our P, Q. It is substituted. We got it 16 by 9. But our question is, they didn't ask variance. They asked standard deviation. Standard deviation, it's nothing but square root of variance. So square root of variance, that is square root of 16 by 9, it's nothing but 4 by 3. So one more problem, that is 20% of items produced from a factory are defective. That is the factory which is producing the products. In that 20%, it is the output what we are getting or the condition of defective state. Now find the probability that in that sample of 5 we are selecting at random. What they are asking, none are defective. We are picking totally that factory, they are producing the product. In the product, 20% is defective. That we have to accept it. That only our probability of success. What is given, the question, what is the condition, what is the, it is putting, we have to accept it. The target, we have to accept it. That is probability of success. Here, that factory, they are producing the output. In the output, 20% are defective. We accepted. That is our probability of success. Fine. 5 we are selecting. So N equal to 5. The question is none, nothing, no, everything mathematically 0. Nothing is defective. So probability of that we have to find. 1 is defective. These are the two questions we have to solve. Now, so the probability of success, 20%. That is 20 by 100, it's nothing but 0.2 defective items. That told you what is the probability of success. So this presentation like this doing, easily we can select the problem comes under binomial or not. This way of presentation step by step, we are able to proceed, then the problem comes under binomial, because there is no word in the question. So far what we discussed in any problem, not even a single word, apply binomial distribution, it is not at all there. This presentation step by step doing, any one step we are not able to get, then which gives an indication that we selected a wrong distribution. Because in the syllabus it's not only binomial distribution, so many distributions are there. Poisson is there, normal is there, more distributions are there. So these similar steps, when we are following, any one step we are not getting, which will make us to make it more careful, somewhere we did mistake, recheck again. That indication we will be getting. Yeah, fine, we will continue. Yes, Q, that is probability of failure. So 1 minus P, that is 1 minus this P, what we got it, we substituted here. So 1 minus 0.2, it's nothing but 0.8. N, we can see it. That is how many actually here we selected. Here also 5, the products actually, total number of products or outputs, anything we can. So the total number of products equal to 5. The first question is none of defective. So the probability of none of defective, it's nothing but x equal to 0. This is our probability. That is a distribution of binomial. Yeah, which is kept here. Yes. Now this is the place for N, because we selected 5 products, and this is the place for P, this is Q, and just I'm putting the tick, the 3 places for X. Our specific target is 0, that is they asked nothing is defective. That is, we will read probability of nothing is defective. Mathematically we will write P of X equal to 0. So we substituted, because this value is 1, this value is 1, the balance is, this value is 1, this value is 1. So this is written 0.8 power 5, which is nothing but 0.32768. The next question is 1 is defective. That is x equal to 1. Everything is same, only x is replaced by 1. So we can see it 1, 2, 3. The 3 places for x, the x is, our question is 1. That's what here also 1. Remaining all the same, the previous what we did, that is nothing is a defective, same one. That is, this is N, this is N, this is P, this is Q. So 5C1, it's nothing but 5, 0.2 power 1, 0.2. Here 5 minus 1, it's nothing but 4. So 0.8 power 4. So the final answer, we simplified and we got it 0.4096. So now another problem, assuming that 50% of all engineering students are good in mathematics. Determine the probabilities that among 18 engineering students, exactly 10, we have to do it. Now, the X is, we know it, that is a specific target of engineering students who are good in mathematics. It is given. Fine. So the 50% of the engineering, the students are very good in mathematics, that we have to accept it. That is only our probability of success. Yes, we accepted it. So P equal to probability of success. 50% equal to 50 by 100. It's nothing but 1 by 2. So good in mathematics. So the presentation. So good in mathematics, probability. We are searching the question. The step by step we are able to put. Yes, we are moving correct the way binomial distribution we selected. Because binomial distribution, the problem which is based on success or failure, yes or no, true or false. Based on this only, the binomial distribution will be. Next, so the probability of success is 1 by 2. Q equal to probability of failure, that is 1 minus P. It's nothing but 1 minus 1 by 2, which is equal to 1 by 2. Now, N is there. So here they told 18 students. Among 18, the number is given. So the number of students equal to 18. So N we got it, P we got it, Q we got it. X, that is our specific target. Exactly they told. Mathematically exactly means equal. Equal 10. So the binomial distribution formula is, which is there, exactly 10. So we are going to read probability of exactly 10. Mathematically it is P of X equal to 10. The probability binomial distribution formula. So everything, this is the 18 is the place occupied in the place of N, P, Q, and this is the place for X. So we solved it. So 18, this is written as it is. Here 1 by 2 power. Here 10 is there. Here 18 minus 10 is 8. So 10 plus 8, it has become 18. The final answer we got it 0.1669. Now the next problem, if the probability of a defective bolt is 0.2, find mean standard deviation for the distribution of the bolt in a total of 400. Now the solution is P equal to probability of success. Yes, we are reading the question. It is given in the question the defective bolt is 0.2. We have to accept it. What we accepted, it's nothing but probability of success. Yes. If we got a P, from which easily we can obtain Q. Yeah, here you can see the presentation. That is defective bolt. That is according to our problem. Q, probability of failure. So 1 minus P, 1 minus 0.2, it's nothing but 0.8. N equal to the total, the bolt is 400. So N equal to 400. What they are asking us to do it, they are asking us to find what is the mean of the binomial distribution. They didn't tell the word also there. Binomial, it is not there. The binomial, P, Q, N, the three, we are able to find. We have to move towards binomial. Now, mean of the binomial distribution, we know the formula, that is NP. So NP, N is 400, P is 0.2. So it's nothing but 80 is the answer. We got it. Mean of the binomial distribution. Variance of the binomial distribution. The question they asked standard deviation. First, variance of the binomial distribution, it's nothing but from which, if you find the square root of variance, it's nothing but standard deviation. So variance of the binomial distribution is NPQ. Now, the standard deviation, that is square root of variance, that is square root of NPQ. N is 400, P is 0.2, Q is 0.8. So, square root of 64, it's nothing but 8. So, the next problem is, the mean and variance of your binomial distribution are 4 and 4 by 3 respectively. So now, this is mean, NP is given. This is 4 by 3 that they told variance. NPQ equal to 4 by 3. From the question reading, this is the information we got it. Fine. Then what we have to do it? That is, probability of x is greater than or equal to 1. Now, so many problems so far we have done it. N is given. So, immediately we wrote it here 0, 1, 2, 3. So far up to where the last we wrote it. According to that, easily without committing any mistake we solved it. But in this particular problem, there is no N at all. Only the thing it is given NP equal to 4, NPQ equal to 4 by 3. There is no information about NPQ. NPQ. These three are there, only we can do the binomial distribution formula. So first, those we have to find the results. P, Q and N. Yeah. So the solution is, so the mean of the binomial distribution, which is equal to 4. So that we have written here, mean equal to NP equal to 4. That we named it as 1. And variance of the binomial distribution is 4 by 3. That is variance equal to NPQ. So that NPQ equal to 4 by 3, that we named it as 2. So this is the only actually possibility we have in our hands. NP equal to 4, NPQ equal to 4 by 3. With this, any simplifications we have to do, we have to get at least one value. So we decided better 2 by 1 we will do. Yeah, we are doing here. That is NPQ by NP. NP, NP, they are getting cancelled. So we are getting cancelled. So Q equal to 4 by 3. This is 4 by 1. So the up it is coming 1 by 4. Q equal to 1 by 3. Yeah, Q we got it. Then P easily we will be getting. Because we know it P plus Q equal to 1. So P equal to 1 minus Q. So the P equal to 1 minus Q, we got it 2 by 3. Substituting in 1. The one equation NP equal to 4. So N into what we got it P, 2 by 3. So N equal to 6 we got it. So N is ready, P is ready, Q is also ready. So 0 to 6 we are able to frame it. Then we selected the problem binomial distribution in a correct way. So the probability of x is greater than or equal to 1. This is the question only we have to solve it. Fine. Now again, the C we are looking that equal sign. 1 is included. Greater than 1, 2, 3, 4, 5, 6. This is the required data for our question, which leads to the solution. This is the wanted, required, needed. This is not at all required data. But here, It's a long procedure. 6 times we have to apply this binomial distribution. Smart work. Only one time. That is total probability 1 minus this. Not at all required this data. We will subtract it. That's what it is done here. So first, the binomial distribution formula. So P of x equal to 0. So now 6, 6. This place is a dominator for n. This place for P, this place for Q. I am putting the tick. The 3 places, they are for x specific target. X equal to this is 0. Yeah, we solved it. This is 1. A power 0 value, exponential law, which is 1. Here, 1 by 3 power, 6 minus 0, 6. So the final answer we got it, 1 by 3 power 6. So x is greater than or equal to 1. So just here we got it, x equal to 0. So this we will substitute. We substituted 1 minus 1 by 3 power 6. So 1 minus, this is 1 by 3 power 6. We can write it 1 by 3 power 6. It is written. So 3 power 6, it's nothing but 729. The final answer we got it 0.99863. Yeah, we will come to a conclusion that the binomial distribution, based on that, we did so many problems. Mean and variance of the binomial distribution. So the binomial distribution, NCX p power x cube power n minus x, and x is taking the value from 0 to n. This condition we focused like anything in this video lecture. Mean and variance of the binomial distribution. Mean of the binomial distribution is NP is the formula. Variance of the binomial distribution is NPQ. So this is the formula. And this is also the notation, specifically 0, 2. At most, mathematically, less than or equal to, exactly equal, at least greater than or equal to, using these inequalities and with the binomial distribution formula, mean, variance, in detail we discussed in this lecture. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.